Lesson number 2, we're going to move on from the parabolas and start working with ellipses. Like before, we have 2 learning targets. We're going to be talking about learning target number 3 is graphing ellipses, and then learning target number 4, writing equations for those ellipses. One quick thing to note, and that is ellipses, they're not functions. If we graph an ellipse, kind of like a circle, we can treat it like a function, but you can see that it does not pass the vertical line test, and so this is not a function. So try not to call it that. All right, an ellipse. What is an ellipse? Well, we know it's an oval, but technically speaking, what would it be? And like a parabola, it has a little more of a technical definition than you might think. So we're going to say an ellipse is the set of points where the sum, so we're adding 2 things together, the sum of the distances from 2 fixed points is constant. And so you can probably guess what those 2 fixed points are called. Those are called the focus, or the foci, just like they were before. So these are the 2 fixed points. And of course, they are on the inside of our ellipse. We've got the major axis, which would be kind of the longer one here, so you can see it in the diagram. We won't write it down. And then the minor axis is the shorter one. And then the vertex, well, we actually have a number of vertices, but that, again, is just anywhere where it changes direction. So those will be key points that we will use here. All right, now, the bottom line is, well, what is the equation for an ellipse? So an ellipse with center at the origin, the equation is going to be x squared plus y squared. But each of these is going to be divided by something. So divided by a squared divided by b squared equals 1. All right, so if you read through your textbook, or if you've seen this before, sometimes you can get a little complicated with what's a and what's b. And basically, here's how I think. I kind of throw all that out the window, and I just remember, okay, whatever is underneath the x, that goes along the horizontal axis, and whatever is with the y, that goes on the vertical axis. If this number is bigger, that means it's going to be one of these wide ellipses. And if this number is bigger, it's going to be one of the tall ellipses. I think we can just leave it at that. We don't have to write multiple equations. All right, so vertices, a, positive a, negative a, 0. Endpoints on the minor axis, okay, all right, we've got that. And then the foci are at positive, negative, c, 0. And of course, they'd be on the vertical axis if we had one of those vertical ellipses. The key thing that you need to know is this right here, and that is the distance from your from the the center here to this value right here. Well, that's c squared. C squared is going to be equal to a squared minus b squared. So that's a fairly important thing. The other thing that you're going to want to know here is, well, if we take any point on our ellipse, so if you're in class, you saw the geometer sketchpad thing, and you saw how that is. Well, if we call this point P, and let's call this F for foci, we'll call this F prime for the other foci. Well, when we add these 2 things together, so we'll say PF plus P prime, or F prime. Okay, well, these 2 things added together are going to be equal to well, all the other points. So like here, we would have these two things added together. That would be equal to the same thing. That would be true all around the ellipse. That's the definition of the ellipse. But here's the other thing that you need to know, and that is, well, that's also going to be this here. So if my points are here and here, well, those things added together are also going to add up to these things added together, and so that would be 2a. All right, so that can help us find a, and so like we said, a is the distance from the vertex, or sorry, the major vertex. Okay, so one of these guys to the origin or the center. All right, let's go ahead and look at some examples. So over here, I got a lot of stuff. Graph the ellipse, find the coordinates of the foci, give the domain and range. Well, if you remember the original equation, we needed to make it equal to 1. How are we going to turn this 36 into a 1? Well, we're going to divide by 36. And if we divide the right side by 36, well, we got to divide the left side by 36 also. On the right-hand side, we got what we wanted, 1. On the left-hand side, I got to divide both these terms by 36. 4 divided by 36 is going to turn into 1 over 9. So I'd have 1x squared over 9. And then over here, this one, well, 9 divided by 36 would be 1/4. So I'd have y squared over 4. And now I have this nice traditional looking formula for an ellipse. All right, so here's what's happening. I'm going to take the square root of 9. Remember, this is like a squared, and so the distance from the center out to the major vertex is going to be the square root of this. So the square root of 9 is 3. That puts me at right here. And of course, I also have -3. This is the b squared thing, and so again, I would have to take the square root of this. This goes up and down, and so the square root of 4 is 2, and -2. All right, there's my vertices, the major and the minor, and I've got myself an ellipse. It also says give the coordinates of the foci. So we remember a couple of things, and that is, well, c squared is going to be equal to a squared minus b squared. And so here we're going to say c, and remember c is the kind of the coordinate of the focus. C squared is going to be equal to a squared, which is 9, minus b squared, which is 4. So c squared is equal to 5. So c is equal to positive negative the square root of 5, which would be approximately 2.2. And so our foci, of course, is going to be on the major axis. So we got our foci here at 2 and 2.2 and -2.2. All right, domain. We're going to say all real numbers, and then x would be in between -3 and +3. And then my range, well, we'll again say all real numbers. This time we go y, and we're in between -2 and +2. All right, well, there's a pretty basic example of how to graph an ellipse. Let's try another one. Slightly more complicated. Again, I want to make this all equal to y, all equal to 1. So I'm going to add this y squared to both sides, and turn that into 4x squared plus y squared equals 64. At this point, I'm going to divide everything through by 64 so that I get my 1. And on the left, 4 divided by 64. It's 1/16, so I'm going to wind up with x squared over 16. And then with this other one, I just have 1y squared divided by 64. And so here you can probably see that, well, this is going to be one of those vertical ellipses because the thing under the y is bigger than the thing under the x. All right, so I guess this one, take the square root of 16, and I get 4. So my horizontal axes are going to be +4 and -4. And then I take the square root of 64, get positive 8 and negative 8. And of course, you can see that's going to make this one of those vertical ellipses. And so my major axis is the y-axis. All right, find the coordinates of the foci. Well, again, we're going to say that c squared is going to be a squared minus b squared. Well, now, obviously, if I take 16 minus 64, I'm going to wind up with a negative number. I can't take the square root of that. So I'm going to make sure that I have the bigger minus the smaller. 64 minus 16. Well, 64 minus 16 is 48. So c squared equals 48. C is approximately positive negative 7.9. 7.9. All right, so that would be right about 6.9, not 7.9. I was looking at the next thing. 6.9. Right there and right there. Okay, moving on to the next one. Here we're on to learning target number 2. Write an equation of the ellipse having a center at the origin, foci at 0, 3, and 0, negative 3, and major axis of length 8 units. All right, so I think it'd probably be a good idea to maybe just graph this out a little bit, just to see what we've got, and that can help us write our function. Not function, our equation. We've got the center at the origin, that helps. I don't have an h or a k value, I don't have to shift it all. I've got foci at 0, 3, 1, 2, 3, and 0, negative 3. Well, if my foci is on my y-axis, that means that this is a vertical ellipse. So, all right, that helps. And then I've got a major axis of length 8 units. Well, that means I'm going to have like the beginning and end, or the major vertices at 4 and negative 4. So it's going to kind of go somehow like this. All right, so how does this all go down? Well, know that the c value is the center to the focus. So that's 3. So I'm going to say, if I put together my c squared is equal to a squared minus b squared, the c is going to be 3. So I got 3 squared. The a squared, well, the a value, remember that's from the center out to the major vertex. That's 4. So I'm going to say 4 squared minus b squared. All right, let's see how this all turns out. I've got 9 equals 16 minus b squared. Well, let's go ahead and I subtract 16 from both sides and get negative 7 equals negative b squared. So that means b squared equals 7. Okay. Well, how does this all help me? Well, here's the thing. I know that the general formula is x squared over something squared plus y squared over its something squared equals 1. Well, let's see. The a squared thing, I know the thing under the y is this one, and so this distance is 4. So 4 squared is going to be 16. That goes under the y. And the b squared, well, that's the horizontal thing in this case, and so b squared is 7. I don't need to take the square root because I want b squared. So that's 7 right there. And hey, look at that. I'm all done. All right, moving on. Another learning target number 2. Well, this one says graph, so I guess this is learning target number 1. You've got a situation here where this doesn't look anywhere close to a regular ellipse function. But, I got the square root here, so what if I just take the square of both sides? That will it's got to make it look less ugly. So the square will take care of the square root. I just have 1 minus x squared over 25. And over here, right, I'd have to square the numerator and the denominator, so I'd have y squared over 16. That actually looks fairly close. If I add the x squared over 25 to both sides, I get what I want. X squared over 25 plus y squared over 16 is equal to 1. And I can go ahead and graph my vertices now. I know that it's going to be a horizontal one because this number is bigger. So I've got 5 and negative 5, the square root of 25. And then 4 and negative 4 down here. Now, I hate to tell you this, but this is kind of one of those weird examples. I'll tell you what it is and then hopefully why. We're only going to graph the top half of this ellipse. Why wouldn't we graph the other part? Well, let's think about what's going on here. If I plug in any of these values, say like 2 for x, well, 2 squared is 4. I get something here, and I get that. But when you take the square root of all that, you only get the positive version, not the negative version. So you're only going to graph the top one when you have something that looks like this. All right. Last one. We've got something that's already in the form, but now we see that we've got a shift. And we can treat this just like everything else that we've shifted. This is our h value, this is our k value. It's going to be the opposite of the sign. So the center, instead of being at the origin, is going to be at positive 2, negative 1. That should be very familiar to you at this point. And then we've got the horizontal vertices, positive, negative 3. So I'm going 3 to the right, I go 3 to the left. My vertical vertices are going to be the square root of this guy, so square root of 16 is 4, so I go up to 4, and I go down to 4. And, well, that's all I need to do. It doesn't ask me for the focus, so I'm not going to do that. And give the domain a range. Well, domain is going to be all real numbers from negative 1 to positive 5. My range is going to be all real numbers from negative 5 to positive 3. All right, that's it for Learning Target 3 and 4.